raise up the, and then I forget
L'Hopital's rule. Very good. So this is limit as x approaches negative infinity. What do I get from at the top?
2x.
Very good. What do I get in the denominator?
2x.
Good. What is the answer?
1.
Very good. Which means y equals 1 is a horizontal asymptote. In case you don't remember, we are going to graph those. The horizontal asymptote means that, like y equals 1, the function will eventually approach it, either from below on one side and from above from the other, or both. It doesn't matter. This is a horizontal asymptote. Like this one is a vertical asymptote. Same concept. Great job. So we come back. We will write 1. We will write 1. And now the moment of truth. I don't trust anything before I check that these two rows work well together. So what does the function do from negative infinity to 0? And this is the interval of what? The function must be
decreasing.
Negative or decreasing?
Good. Is it true? Is it decreasing from 1 to 0?
Yes.
Good.
Yes.
What should the function be doing between 0 and infinity? So this is the interval of decreasing, and between 0 increasing. Is it? I have to make sure that the numbers match. Because if this is 0 and this is negative 1, I'll say something is terribly wrong. How can the function be increasing? The derivative is positive, but the function goes from 0 to negative 1. There is no such thing. And that's it. That's all I needed you to show. Anything else? Anything else? Okay, so we are moving on now to 2.2. And just to make sure that this is clear, let me write it one more time in the summarized form like I like it. So first, derivative test. Okay. So I'm talking about f prime. If f prime is 0 or undefined, and the sign changes, like we just showed in all tables, we showed the sign of the derivative. If the sign changes from negative to positive, this gives a point of minimum, relative or local minimum. The second possibility is when f prime is 0 undefined, but the sign changes from positive to negative. And this is typical for a relative max. In this situation, in which f prime of x, it's either 0 or undefined, but I have here positive, positive, or negative, negative, or negative, negative, positive, positive, nothing. This is not a point of extrema. And we had several examples. Clearly a minimum, clearly nothing, clearly a minimum. So this is this situation, either plus plus or minus minus. And you understand it can be 0 and minus minus. It can be undefined and plus plus. So this is the first derivative test. So one more time, what do we learn from the first derivative about the function? A lot. We learn the intervals of increasing, decreasing, decreasing, increasing. We learn max, min. Okay? And of course the critical numbers. The critical numbers are given by the first derivative anyway. Okay. Moving on now, we'll continue with 2.2, in which we are going to look at the second derivative. And let's see what we learn from the second derivative now. So I'm going to, please open your books on page, we're still not graphing yet, page 217 to 18. And I would like to choose any problem in which we want to find increasing, decreasing, and what the second derivative is giving to us. So maybe we should start by discussing that first. So second derivative. Let me summarize here also the first derivative one more time. The first derivative gives intervals of increasing, decreasing, and it gives max min. And of course, it also gives critical numbers. I should have put critical numbers first, but you know what I mean. These are all important. So this is a starting point, and then these any order. What does the second derivative will say? The second derivative will give us, since I have max min here, I'm going to put here, inflection points or point. What else it will give us? It will not give us intervals of increasing, decreasing. This is already taken by the first derivative. It will give us an intervals of concavity. Of course, these two go together and these two go together. So let me give you an example to understand what that means. So this is an example which is a function very well known to us, like f of x equals x to the third. It is very clear that this function is always increasing. It will not have a max min. It will have a critical number, but it will never, the derivative will never change sign. It will not have intervals of increasing, decreasing. It's always increasing. On negative infinity to infinity, the function is increasing. No max min. But something very interesting happens here. The function is increasing all the time, but there is a point somewhere here where the function changes concavity. What does that mean? On this piece, it's opening downward. And on the other side, after this inflection point, it opens up. So this is concave downward. And this piece is concave upward. We like to say it holds water. It does not. That's silly in a way, but even my own professors would say that. So,
sorry
yes?
to interrupt, but
you're not interrupting.
Make sure I understand this right. So, the concavity, is that the concavity of f of x or
yes.
the first derivative?
This is the function. This is the function, and the concavity, the inflection point, will be given by the second derivative.
Okay, so the relationship is between the second derivative to the original function.
Absolutely, like here.
Okay.
What do we learn? Very good point. What do we learn from the first derivative about the function? Intervals of increasing, decreasing, max, min, and critical numbers. What do we learn from the second derivative about the function? Intervals of concavity and inflection points. Very good point. Thank you. Okay, so I would like to choose a problem. Let's start with the polynomial because those are the easiest to handle. Page 218, and then we can branch off to something else. Page 218, let's start with 23. And here's the function. Keep an eye on what I copy. Just kidding, sometimes I do copy something else. Now, the question here is, I don't care about what they ask at this point because we're not ready to graph. So what I'm asking here for this problem is everything we should know from the first derivative, what the first derivative gives, and what the second derivative gives or tells us about the function. Okay, we're going to start our table. And then we will give an attempt to graphing. And what do we start always with? Always. Anyone?
0.
Negative and positive infinity.
So we start with the domain. We always start with the domain. Notice what happens now. I have the domain on the first row. Like we had before, the first derivative, the function. Now please note that the second derivative is the last row. I promise I will not add anything else to the table. This is it, moving forward. Just these 3 rows. Very good. Since we want to look at the function also, can anyone tell us what is the limit of the function when x approaches negative infinity and when x approaches infinity? Anyone? Anyone I haven't heard say anything yet?
Is it infinity over infinity?
This is not a ratio. I cannot write infinity over infinity. This is a polynomial function. Noor, would you tell us what is the limit? Noor, are you with us? I'm asking you to answer in case you haven't heard. Anyone else would like to give us an answer?
Would it just be infinity?
Absolutely. The most powerful term, this doesn't even matter. The most powerful term is x to the 4th. Thank you, Savannah. It's infinity. Very good. And that's where it goes. When x approaches negative infinity or infinity, the function approaches infinity in both directions. Perfect. The next step is I need to investigate the first derivative. Where is my starting point now? What do I need to do next? What
f prime of x.
Of course, f prime of x. Can anyone give us f prime of x?
Four x to the third
Yes,
minus 6x.
squared.
Yep. I think it's
Perfect.
the last term.
I will immediately factor out 2x squared because we have to. And tell me what you have left in parentheses.
2x minus 3.
Very good. Since the degree is, what is the degree of this polynomial? Anyone?
3.
Good. Then we have 3 solutions. Can anyone give us 3 solutions? Gabby, will you give us 3 solutions?
Is one of them 0?
Say it again.
0?
Yes.
3 over 2. A 2 over 3. Or 3. I don't know the last solution.
Alex, will you help?
Yeah, I'm not so sure.
Brianna?
I do not know either.
Say.
I'm lost as well.
I'm sorry?
I'm lost as well.
But this is x squared. We just did a problem like this a minute ago.
Be 0.
Is
Of
it
course.
another 0?
Of course. We just talked about it. 2 solutions, x equals 0,
Yeah,
right?
I think it was just confusing because when we did it on the last one, I said 0 and you put the 0 for 2 of them. And then when she said 0 this time, you only put it for 1. So that, for me, that makes
Because she
sense.
didn't say 2, or I didn't hear 2. It's possible that she said, I apologize if you said that, but I didn't hear 2. Good. So I will put 0 and 3 over 2. I will write the corresponding zeros. I have to find immediately these 2 points, the y values. So I'll share my screen. I will put in the function in the graphing calculator. I will delete what I had. Let me see, this is 4, never mind. So 4x to the third, where is my function? It's x to the fourth, sorry. X to the fourth minus 2x cubed. And I go to a second and of course 0 will be 0. And when I plug in 3/2 or 1.5, I get that. I don't like it. I would like to have it as a fraction, but for now, let's say it's okay. So this is negative 1.6875 and 0. I'll stop sharing. Okay, now let's look at the derivative, and I need the sign of the derivative left, middle, right. Which quantity you will not waste your time with? Anyone? Alex?
Can you repeat the question?
Yes, I need to find the sign and which quantity I will not waste my time with.